We're told to describe a reasonable domain for each situation and explain how to modify the graph to show that domain. So we're starting with situation A, live stream activity. So a school club is hosting a 12-minute live stream announcement. The number of new viewers joining per minute Y is modeled by, we have this quadratic equation here, where X is the number of minutes after the live stream starts. So you give me how many minutes after the live stream, I put that for X, and I'll tell you how many people are joining per minute. Now, if we just graphed Y equals all of this business, we would get this parabola right over here. But when we think about the actual situation, we realize that having negative time does not make sense. And also, that would be, I guess, before the live stream is actually starting. And then it's only lasting 12 minutes. So we shouldn't have time that goes beyond the 12 minutes. So if I'm thinking about the domain here, so the domain to me would be that X would be greater than or equal to 0, or 0 is less than or equal to X, and which is going to be less than or equal to 12, where X is the time in minutes. This is the X-axis right over here. Now, what would that graph look like? Well, essentially, we would only be showing the part of this graph from here to here. So let me just trace that out. So what I'm doing in blue would now be the graph of the function with this restricted domain. That makes sense. We would not look at the time beyond 12, so we wouldn't graph anything there. And we wouldn't look at the time below 0, so we wouldn't graph anything there. Let's look at another scenario. So let me scroll. Let me get rid of this one and scroll down. So in situation B, theater light setup. We are told a row of stage lights is numbered 1 through 10. The amount of cable Y in feet needed to connect light X to a box is modeled by. All right, so once again, they have graphed this entire expression. But what would the domain of this actually look like? And actually, we do another color here. So let's think about this domain. So domain in this situation, well, the X's is the control box number. And those are numbered 1 through 10. I'm assuming it's only the whole numbers 1 through 10, that you can't have box number 1.5 or box number pi. So I would say X is a whole number. X is whole number. I could say in between 1 and 10 included, or I could say where 1 is less than or equal to X is less than or equal to 10. Now, given this restricted domain, what would that look like? Well, I wouldn't have all of these points on this curve. I would essentially have when X is equal to 1, I would have that point. When X is equal to 2, that point. X is equal to 3, that point. 4, 5, 6, 7, 8, 9, and then 10. So the graph of this function with the restricted domain would only be these little points that I have colored in red. That would be the ones where you could actually get a input an X value that would give you a Y value that makes sense in this situation. So this function should really only be defined for where X is a whole number between 1 and 10, including 1 and 10.